Hello everyone. In today's video, we will be proving the angle bisector theorem. Before we start proving the theorem, let's see what it states. The angle bisector of an angle divides the opposite side in the ratio of the sides which contain the angle. In other words, if we have a triangle YOZ such that OX bisects angle O, then YX by XZ is equal to YO upon OZ. For convenience, let me represent YO by A, YX by B, XZ by C and ZO by D. Then A by D is equal to B by C whenever angle YOX is equal to angle ZOX. Now let's start proving the theorem. We begin by observing that YX and XZ form a straight line YZ. Additionally, point O is common in the triangles YOX and XOZ. Now if we draw a perpendicular from O to YZ, say OP, we realize that triangles YOX and XOZ share this perpendicular. This perpendicular is common in both the triangles YOX and XOZ. Consequently, when we take into consideration the ratio of the areas of triangles, it corresponds to their bases. Let's see why. Area of YOX is equal to YX, that is base, which is B, into the height, say H, upon 2. Similarly, area of ZOX is ZX, that is C, into the common height H by 2. We can simply strike off H by 2 to simplify it to B by C. This result is quite important, but notice that every other line like XO, which splits the triangle into two, gives this property to the triangles. We are yet to use the fact that XO is a special line which not only splits YOZ into two triangles but also bisects the angle O. Also because we have established a relation with regards to the ratio of areas, let's stick to it and think about representing the areas of triangles such that it involves the angle theta. So how can we do that? Maybe the sine version of the area of triangle is what comes to your mind. If we have a triangle with its side lengths equal to A and B such that the angle separating them has its magnitude theta, then the area of this triangle is given by A into B sine theta divided by 2. It is our very own base into height by 2 formula, just in disguise, I think. So if we take a base as A and drop a perpendicular from the opposite side to A, because the hypotenuse has its value B and theta is the angle separating A and B, using the definition of sine theta, in this right angle triangle, P by H is equal to sine theta and H is simply B. Multiplying both the sides by B gives us the height of this triangle equal to B into sine theta. Now we know that the area of a triangle is base into height by 2, which is A into B sine theta upon 2. Wasn't that easy? Using this version, area of YOX is equal to A into T sine theta upon 2. Similarly, area of ZOX could be represented by D into the common side T by 2 and into the sine of the angle separating D and T, that is sine theta. So because angle YOX and ZOX is the same, sine theta is the same, we can simply strike it off. Also because T is the common side in these triangles, it will receive the same treatment, just as half receives. Now we deduce that area of YOX upon area of ZOX is simply A by D. But wait a second, didn't we derive that it was equal to B by C? Yes, we did. So if two things are equal to the same thing, they must be equal to one another. This is how we prove the angle bisector theorem. That is, B by C is equal to A by D. Before ending this video, let me clarify that if the triangle YOZ was an obtuse angle triangle, we can follow the same procedure to derive the result. It's just that I naturally tend to draw acute angle triangles. So just for fun, you can try working it out, the obtuse angled case I'm talking about. And with that, the video ends. If you like this video, give me a thumbs up with any of your fingers, share it with your friends, and the most important thing, subscribe to my channel. So bye bye. Hello everyone. In today's video we will be This result is quite helpful, but notice that every line that splits the triangle YOZ into